Thank you. So, okay, hello everyone, also from my side. As the moderator said, I'm Toma Buchinsky, CEO of Adastra Germany, and a data architect also in the same time. In this session, we will try to bring more clarity. What does it mean, data lakes in a multi-cloud platform? And this will be me and Prashant will present two real use case studies at the end of the presentation. Some words about Adastra. We are an international company with more than 24 offices worldwide. In Germany, 6 of them are in Germany. We are over 2,000. We have over 2,000 consultants worldwide, and for more than 25, 26 years, the main focus of our activities has been data and analytics, and actually we are a consulting company, service provider. In the last 5 years, we are doing more and more, implementing more and more in the cloud. So, MultiCloud Analytics. This is a report from Gartner, which is published 3 months ago in December last year. And according to the Gartner analysts, through 2026, 90% of the data management tools and platforms that fail to support multi-cloud and hybrid capabilities will be set for decommissioning. Okay, I would not say that in 2026 there will be special law, which will say, okay, in 3 years you have to have only multi-cloud applications. But I could imagine, and most probably, you will be less competitive, you will have less competitive advantages to your competitors if you are still only on single cloud or dependent on the one cloud platform. So what we see from our experience, how is the usage of cloud nowadays? At least most of the companies, at least mid-size and big size, are utilizing at least one cloud platform. What is also changing is the way how cloud is using, not only as a storage of files and data, but also not only as a hosting web server, but more and more hosting complex micro applications based on microservices or complex machine learning applications. Many of the large companies, at least, announced in the last 2 years partnership not only with one cloud, but also a public cloud provider, but also with at least two, and announced that they are following a multi-cloud strategy. So let's see 2 examples from the real life. The first example is from a global manufacturer, and they also announced strategic partnerships with AWS and Azure, and started big projects. One of them is in production and logistic data lakes, and support also from the cloud provider. They're implementing really good and complex solutions based on all cloud native features of AWS, for example, for data processing and machine learning, Glue, EMR for analytics, data analytics, Redshift, and so on. At the same time, they're implementing in the area of sales analytics, another solutions on Azure, also supported by the cloud provider, also utilizing native cloud technologies like Azure Databricks for data processing and analytics, Azure Data Factory, also for scheduling and data processing, Azure SQL, Power BI as visualization. There's similar, another example from a large European bank. They are doing their sales and cloud analytics in Google, again with massive usage of cloud native technologies. And for the credit risk, they are migrating their old credit risk data stored in engine in Azure. So the question is this multi-cloud? Let's first see what is actually multi-cloud, and this is the definitions from Wikipedia. This is the usage of cloud computing and storage services in a different cloud providers based on a single heterogeneous architecture. Or in other words, to have a portable application. So also Gartner, they are defining 2 types of multi-clouds. One is redundant, where you have the same workflows running in a different cloud platforms, or composite, where you have one applications, but the different components of this application is running on a different clouds based on the, let me say, the better features in the different cloud platforms. In either case, you need something unified to manage this diversity. So what are also the major drivers for the end users to go in multi-cloud? One of the most important, especially here in Europe, if you are following the newspapers, especially the specialized newspapers and the business newspaper, Handelsblatt or so on, there are a lot of articles, oh, it's dangerous to go only with one cloud, and we're European, you are getting dependent on the American or Chinese cloud platforms. But that means one of the driver to go in the direction of multi-cloud is to avoid this so-called vendor lock-in. Another driver is, anyway, for some reasons, mostly political, it could happen that, let me say, in Eastern Asia, it's not allowed to do something on AWS or Microsoft, but you have to use Alibaba. And the opposite, maybe you develop something in China, but you want to deploy this also in the United States, but you are not allowed to use Alibaba Cloud, for example. These are some major drivers. So, coming back to this previous example, let me see, in this bank, and it's created this application which is developed for Azure. So they could not just easily port this to Google Cloud. It will not work because they're using already technologies which are running only on Azure data cloud, Azure Cloud. That means it's not a multi-cloud application. But however, if you follow some guidance, even already starting with the design of your applications, you could avoid this vendor locking, and you could save your investments in developing complex cloud-based data applications. These are what our data engineers and software engineers could define in the last years. Already during the design, just think about portability. Try to avoid using specific libraries from a particular cloud provider, and use as much as possible so-called vanilla libraries, for example, vanilla Apache Spark and so on. Avoid store procedures, for example. It's classical use case where it's difficult to migrate. And use as much as possible reusable components. So in case you have to migrate, that it's only some central components should be adjusted or changed. So applying these guidelines, actually you could reach something like this, where you have big part of your investments in developing, let me say, data lake application, implemented with portable code. And this is doable, but still deploying this on a cloud-native components, like, let me say, you develop data pipelines with Apache Spark, and you deploy this on AWS, but you deploy on EMR or AWS Glue, or you deploy the same logic on Microsoft Databricks or Microsoft Synapse, or Google Dataproc. That means this is one approach, and this is exactly what we are doing with this first global manufacturer. It's a customer first, and we are helping them exactly to develop their customer data lake in this way that once develop a business logic could be deployed at least into cloud platforms, AWS and Azure. So, of course, the question is, could we go further and optimize this unification further? That's even in the previous case. Okay, I don't know why it's. I'm pressing the wrong button. That means in this case, the infrastructure as a code and the CI/CD pipelines are components still dependent on the cloud platform. But the question is it possible also to optimize this, to make also these components unified, or to have such architecture where really you develop something once, including business logic, including infrastructure as a code, and deploy it at any platform. So luckily, the recent developments, technological developments, are enabling this, and especially the coupling of meanwhile very known technologies like Kubernetes and Apache Spark. It's enabled to develop exactly such architectures and applications. And Kubernetes, this is an open source platform which really give you the freedom to take as much as possible from all kinds of platforms like on-prem, hybrid, or public clouds, and to deploy your workloads there where you need them at most. Apache Spark, for the last 10 years, it has been established as one of the major technologies for developing applications for processing big data, for implementing complex machine learning applications. And since 2018, it's possible to use Kubernetes as alternative for Apache Spark Cluster Manager. Or let me say, you could have this architecture where you, instead to use the native components of the cloud provider, for example, AWS EMR for Apache Spark runtime environment, or Dataproc, Google, you are using Kubernetes and deploy your Spark workloads in Kubernetes. Of course, it would be too perfect to have this. There is still some very small part of infrastructure as a code which remains cloud-specific, but it's reduced really to the very, very, very small volume of piece of code. And actually, my colleagues Prashant now will present exactly two such case studies which are based exactly on similar architecture. Prashant, the stage is yours.
Thank you so much, Toma, for explaining the concept. Now I'm here for discussing the interesting part, how we did that. So the first use case where we used cloud-agnostic solutions, or why we are saying it cloud-agnostic, because the tools and technologies that we use are applicable for all, I would say, major public cloud providers. So first of all, from where we should start? We know that, okay, this is useful, this is futuristic, and this will enable us in terms of cost optimization to adapt to scale up our application in future. But how to do that? So the starting point can be containerization or container architecture. What container does, you can break your complex application into different microservices. Those microservices can be easily maintainable. You can extend them in future if you want to, scale up your application. Side by side, there are lots of different advantages of this microservice architecture. I would say we cannot go in that depth. The thing, if we are dealing with containers, imagine if you have 20 containers, 50 containers with your application, it's easy to maintain them. But we're talking about production-grade applications. We're talking about thousands of containers running in one environment, and then we have different environments. Then we need a tool who can manage these containers, who can orchestrate these containers on different environments. So here Kubernetes comes into picture. There are different tools also, you can use Docker Swarm for orchestration of containers, but we are focusing on Kubernetes because this is open source. This is compatible with different cloud providers. And with Kubernetes, you get optimal hardware utilization because you can just shut down your resources which are not using your containers. It gives you portability. You can just deploy this Kubernetes solution to any public cloud you want. There are lots of public cloud providers which gives managed Kubernetes services also. It's also auto-scalable. It's self-healing. If something goes wrong with your application, it's auto-starting and self-healing. So with this, you can just manage your workload on different cloud providers or mixed architecture. The key aspects of Kubernetes, how it is dealing with the challenges. First of all, you have a unified code base. Your code base for Kubernetes workflows or for Kubernetes resources, you can deploy this on any cloud. So it's kind of single source of truth for all your business logic resources. Similarly, you can set up the monitoring, the security with Kubernetes that is applicable on all the cloud providers. For security, if you are dealing with multiple cloud vendors, it's definitely the crucial part that it gets complex and complex. So the thing is, with Kubernetes, you can add one additional layer of security. Like you are securing your resources at Kubernetes level. It's not like there are some features definitely provided by the public clouds itself, but you can secure your application at the very bottom layer of Kubernetes itself. So with all these aspects, now you have better control on the cost of resources because it is more managed by the Kubernetes. Okay, now we'll talk about two examples, real-time examples where we implemented this concept successfully. The first use case was for a really huge automotive manufacturer. They wanted a centralized data analytics platform for the data coming from different data sources. This is a part of the regulatory requirement that they wanted the data to be first unified, and then the whole platform should be portable and extensible for future needs. Why we are focusing more on portability? Because our client infrastructure was not ready for this approach, to be honest. So we started developing this concept on AWS first. Once the infrastructure was ready, we actually migrated the whole solution from AWS to their on-prem OpenShift environment. On the right top corner, you can see it's a bird's-eye view of the data pipelines, which are completely cloud agnostic. You will not see any component which is bound to any specific cloud vendor. We are using Kubernetes for a computation platform. We used Apache Spark or PySpark for all the data modules. We were running our workflows on Argo. Argo is a new Kubernetes native workflow engine, you can say, is similar to Airflow. You are scheduling your jobs with Airflow most of the time. So this is a thing we can use like any CI/CD solution. So we went for Bamboo. It's also not any cloud specific. So with this solution now, we have fully automated ecosystem from the code development to the testing and to the final deployment of workflows. With this solution, we are now processing almost 35 to 40 million records every day per job. So it's quite robust. The configuration management, overall configuration management was done by Helm. It's also Kubernetes native. This is also, I would say, cloud agnostic now. If you see in this solution, you will not find any cloud-specific thing. We actually migrated this from AWS to OpenShift. If you want in future, you can also apply this to Azure or to any cloud. For monitoring, logging, we used ELK stack, Grafana, and Prometheus. So in the second solution, if you see, this is quite new. It's a really, again, a big client, EU bank group. They are looking for a cloud-based, completely cloud-based solution, but on the other hand, they want this to be it should not be any specific to any cloud provider. So it should be like avoiding a vendor lock-in. So the key aspect, again, for this design principle is Kubernetes. If you are using Kubernetes, then it's kind of you are always on the safer side. But their whole infrastructure was on AWS using ELK, is again managed Kubernetes from AWS. For object storage, they use S3, running a Spark job on Kubernetes. So wherever Spark goes with Kubernetes, they are never dependent on any cloud provider. They use SageMaker, Jupyter Notebooks, Airflow, Jenkins for CI/CD pipelines. And the best part here, like the whole infrastructure itself is coded with Terraform, so it's portable. You can deploy this infrastructure through CI/CD pipeline on n number of infrastructure environments, you can say. And whenever you want to change this infrastructure, you will just tweak that Terraform code a little bit, and it will be deployed side by side on all the environments. The core benefits, again, it's avoiding vendor lock-in. You are running a Spark on Kubernetes, which gives you really cost-optimized solution. Like all your executor nodes are only available when they are needed, up to the scale that you are configuring. The application components are completely managed by Kubernetes, and you can shift this solution to any cloud provider anytime. So what are the key takeaway out of this whole discussion? Like MultiCloud is there to help you enabling your application or your a data analytics platform for any cloud provider, but on the side, if you see the complexity is increased, so we have to be more vigilant about the data security and data governance. It definitely avoids vendor lock-in, but you have to be really careful while choosing the right cloud provider or the services from those cloud providers. Otherwise, you will end up with a really complex infrastructure with not so cost-effective. And last but not the least, you have to opt for containers, because there are lots of applications we found they're still running on virtual machines, or like container is also one kind of a virtual machine for sure, but they are not even believing on this concept. But if you are more futuristic, if you are more cloud agnostic, then you should definitely go for containers. So with this, I'll hand it over back to Toma for the conclusion, and then we'll go for a Q&A session. Thank you.
Thank you, Prashant. Actually, yeah, this is the conclusion is not a must-have, but the most important is this avoidance of the vendor lock-in. So what is also important to mention, it does not mean that we are propagating against the hyperscalers. It's the opposite. Actually, especially in Europe, the customers are still conservative regarding the usage of cloud because of this eventual vendor locking. But when they know, okay, it's not that dramatic, and I have also means to control this, then I will start to use AWS, Azure, or Google, and but I will know, okay, if something changed, I could migrate easily to the next hyperscaler. This is what I wanted to add at the end. Any questions?
First of all, I'd say let's give an applause for Toma and Prashant. And yeah, like Toma said, do we have any questions? Here we go. Feel free to go ahead.
Okay, thanks a lot, guys, for the presentation. Just one thought is, I think this is possible because of the core concept of compute and storage being disaggregated now, right? Which is fantastic. But then what happens to the data?
Yeah, this is a very good question. Of course, especially in the case of where the location are anyway separated because of the different regulations, the data anyway are separated. So of course, first, when we are talking about the use case of possible exit from one cloud and porting to the new cloud, anyway, you have to migrate all the data. This is another story. If you want to have a purely redundant approach, as Gartner defined this, the multi-cloud, of course, you have to copy the data, at least the rough data, the raw data on both platforms, or more platforms, and but run the processing on these different platforms. So this is maybe very different approaches. But what is important, we have another customer from this is one of the largest producer for some medicine devices worldwide, and they said, okay, for some reasons in the United States they're using massive AWS, in Europe this Azure, but they have a central data science team, which also dispersed all over the world. But they said, we want these guys to develop exactly in the same way. These are exactly the same machine learning procedures. And we don't want to have something specific in Europe and something else in the United States, because the only difference is the name of the cloud providers, and that the data in the United States must be in the United States, and the data in Europe should stay in the European Union. And that's why they had exactly such need for portable solutions and a really unified way to run their machine learning process. And one of the possible solutions is exactly this. But yeah, the question is regarding data, should we replicate our data? It's, in my opinion, what is the cheapest from all these cloud services is the storage. What is more expensive is processing. So just replicating data should also not be a big deal.
Mm-hmm. Thank you very much. Any more questions as of now? I don't don't think so. So, of course, Adastra is still here with the booth in the exhibition. So if you have any things to follow up with Adastra or any questions, any feedback, feel free to share it there. And also, of course, in the virtual booth, also for our virtual attendees, which will remain open even after our live event, which concludes today. So thanks again, Toma and Prashant, for giving the talk.
Thank you also.